What specific problem does the CONTEXTCITE method aim to solve in the context of language models? And how is this problem different from generating citations?
The CONTEXTCITE method aims to solve the problem of context attribution, which involves identifying the specific parts of the context that contribute to a generated response from a language model. Unlike generating citations, which typically involves training models to produce references that support a statement, context attribution focuses on pinpointing the actual sources that influence the model's output. This distinction is crucial because context attribution can reveal misinterpretations or the use of pre-trained knowledge rather than context, whereas citations may not effectively highlight inaccuracies. CONTEXTCITE seeks to provide a more direct understanding of how context affects model responses, thereby enhancing the verification of generated statements and improving response quality. This method allows for a more nuanced evaluation of the model's reliance on context, which is not achievable through traditional citation generation.
How does the proposed CONTEXTCITE method work? Please illustrate its step-by-step process, detailing the role of surrogate models and how ablation vectors are used.
The CONTEXTCITE method operates through a systematic process that involves several key steps. First, it samples a training dataset of ablation vectors, which are binary vectors indicating which sources from the context to include or exclude. For each sampled ablation vector, v_i, the method computes the probability, fv_i, of generating the original response based on the modified context. Next, a surrogate model, hat_f, is learned to approximate the relationship between the ablation vectors and their corresponding probabilities, allowing for efficient computation and interpretation of the effects of including or excluding specific sources. The surrogate model is designed to be linear and sparse, meaning it assigns weights to sources that reflect their importance in generating the response, with the sparsity ensuring that only a few relevant sources are highlighted. Finally, the weights from the surrogate model are used as attribution scores, effectively linking the generated response back to the individual sources in the context.
Can you provide a simple yet illustrative example demonstrating how CONTEXTCITE attributes a generated response to specific parts of the input context? Walk through the main algorithm steps with an example response and the related context.
To illustrate how CONTEXTCITE attributes a generated response to specific parts of the input context, consider a scenario where a language model generates the response, "The capital of France is Paris," based on a context that includes sentences about various European capitals. The main steps of the CONTEXTCITE algorithm would be as follows. 1. Sample ablation vectors. The algorithm first samples a set of ablation vectors, which represent different combinations of context sources, e.g., sentences about capitals. For instance, one vector might exclude the sentence, "The capital of France is Paris," while including others like, "The capital of Germany is Berlin." 2. Compute response probabilities. For each sampled ablation vector, the algorithm computes the probability of generating the original response. If excluding the sentence about Paris significantly lowers the probability of generating the response, this indicates that this sentence is a key contributor. 3. Learn a surrogate model. A linear surrogate model is then trained on the ablation vectors and their corresponding probabilities. This model captures the relationship between the context sources and the generated response, allowing it to assign important scores to each source. 4. Attribute scores. Finally, the weights from the linear model are interpreted as attribution scores, indicating how much each source contributed to the generation of the response. In this case, the sentence about Paris would receive a high score, confirming its critical role in the model's output. Through this process, CONTEXTCITE effectively identifies and attributes the specific context source that led to the generated statement, demonstrating its utility in understanding model behavior.
What are the theoretical benefits of using CONTEXTCITE compared to existing methods for citation generation or corroborative attribution? What improvements does it offer?
The theoretical benefits of using CONTEXTCITE compared to existing methods for citation generation or corroborative attribution lie in its focus on contributive context attribution, which identifies the specific parts of the context that lead to a generated statement. Unlike corroborative methods that may fail to find attributions when a model misinterprets information, CONTEXTCITE can pinpoint misinterpretations, thereby enhancing the model's ability to verify or correct its statements. Additionally, CONTEXTCITE employs a linear surrogate model that efficiently attributes outputs to individual sources, allowing for a clearer understanding of how context influences responses. This method also emphasizes sparsity, indicating that only a few sources are often relevant for a generated statement, which can improve response quality by pruning unnecessary context. Overall, CONTEXTCITE provides a more precise and actionable framework for understanding and improving language model outputs.
How is the effectiveness of the CONTEXTCITE method validated? Describe the experimental design, datasets used, and metrics for evaluating its performance.
The effectiveness of the CONTEXTCITE method is validated through a systematic experimental design that involves sampling ablation vectors and computing the probabilities of generating responses based on these vectors. Specifically, a training dataset of ablation vectors is created, and for each vector, the probability of generating the original response is calculated. The performance of CONTEXTCITE is evaluated using two key metrics: the top k-log probability drop, which measures the impact of excluding the highest scoring sources on the response's probability, and the linear data modeling score, LDS, which assesses the correlation between predicted effects of ablation and actual probabilities. The datasets used for these experiments consist of various contexts and queries, allowing for a comprehensive evaluation across different scenarios. By comparing the performance of CONTEXTCITE against other attribution methods using these metrics, the study demonstrates its ability to effectively identify contributive sources for generated statements.
What limitations or potential drawbacks does the CONTEXTCITE approach present, especially concerning its accuracy or generalizability in real-world applications?
The CONTEXTCITE approach, while effective in attributing generated responses to specific context sources, may present limitations regarding its accuracy and generalizability in real-world applications. One potential drawback is that the reliance on a linear surrogate model may oversimplify complex relationships between context sources and generated statements, potentially leading to inaccuracies in attribution scores. Additionally, the method's effectiveness is contingent on the quality of the sampled ablation vectors. If these vectors do not adequately represent the diversity of possible contexts, the model's predictions may not generalize well to unseen data. Furthermore, the sparsity induced in the surrogate model through techniques like lasso could overlook relevant sources that contribute to the response, thereby affecting the completeness of the attributions. Lastly, while the method aims to be efficient, the computational demands of training and evaluating the surrogate model may limit its scalability in real-world scenarios with large and diverse datasets.